Hello everyone. Thank you for being here with us for our tutorial, Deep Learning for Search and Recommender Systems in Practice. I'm Bo from LinkedIn. My colleague, Zhou Tong, Huiji, Weiwei, Sandeep, Jun, Xiaowei, Junshi, Shida, Yinzhou, and myself will present this tutorial to you. We will have both presentations and hands-on sessions to help you learn how to build deep learning-based search and recommender systems step by step. I hope that you will enjoy the tutorial and learn the things useful for you. Here's the agenda. We'll start with introduction, and we'll talk about the basis for the search and recommender system, query and user understanding. And after that, we'll talk about the retrieval stage for search and recommendation, and there will be the ranking for search and recommendation. Jun and I will talk about the introduction first. Introduction. I will first give an overview about the search and recommender systems. Then I will introduce the applications at LinkedIn. And Jun will talk about the tutorial overview. So nowadays, it may be fair to say that we cannot live without the internet. But the big challenge from internet is information overload. And the search and recommendation are two basic ways to address the information overload, help people get useful information from internet among billions of websites. Companies in this figure are examples of big names who are based on the search and the recommendation. Let us take a look at the search system. A user provides a query to a search system, then certain system returns a list of most relevant results based on the system's judgment. Like in LinkedIn job search, a user provides a job search query, and our job search system requires a list of relevant job results. So for a search system, you have the input raw query from users, and the system do the query understanding. And the other side, the documents, which are information users are looking for, also gonna be input over your search system and through the document understanding. And after we understand the required document, then we can retrieve a list of candidate sites. And based on those candidate sites, we can rank the most relevance on the top to give the best user experience. So this is a general architecture for a search system. Let us take a look at a recommender system. For recommendation, users do not provide queries. So recommender system will guess the user's interest and provide a list of documents mostly interested to our users. Like for LinkedIn job recommendation, even you don't provide any job search queries at our job homepage, our recommender system will provide a list jobs the system rank as most relevance to a user. So for a recommender system, we have the user profiles as an input. Based on user understanding, we can really figure out what kind of things interest to our users. On the other side, we also have documents, which are information users are looking for through the document understanding into our recommender system. Based on this two understanding, again, we retrieve a list of candidates with this most relevant or interest to our users. Then we do the ranking, ranking the most relevant ones on the top. If we put the search and recommender system together, we'll find that they have a lot of common things. For example, they all have the document understanding part. which the document are the information users are looking for. And they also have two stages. You need a retrieval document first, and you rank the candidate side from the retrieval stage. Because normally the document has a large amount of candidates over there. You cannot rank them all. That's why you need to do retrieval first and do the ranking. For search, you have the query as the input. For the recommender, has user profile as the input. But sometimes they may mix together. For example, for personalized search, you have both row query as the input, also have the user profile as the input to the personalized search. If you do the conversational AI, of course, you also have all those together, query, user profile, and you also do multiple rounds, get the interactive communication with users. Let us take a look at an example. Here's a linking, search, and recommendation ecosystem. So for the search, you have raw query comes in. For recommendation, you have member profile coming. And we have online assistants to help user to input the query, like spelling check, query suggestion, auto compilation. And both query or user profile need to go through text processing, such as language detection, tokenization, normalization. And on the left side, we have the to understand the user intention. For the query, we have query understanding to understand the query intention. For the user side, recommender side, we understand the profile. And based on all those understanding, then we can select the set of candidates from a large number of the documents through this document store. It's basically a retrieval or targeting stage. And after that, we need a ranking function to rank the most relevance on the top to give the best user experience. It's a general architecture for linking, search, and recommendation ecosystem. And like we mentioned before, if you do multiple rounds, right, use a give a query, you ask questions, we get more input from user and return the more relevant results. And this interactive way become a conversational AI. Which you can think as an interactive search and recommendation system. Now let us take a look at the applications at LinkedIn. First, you come to LinkedIn to look for jobs, and we have job search. You input the job search queries. Our job search system will return a list of the relevant jobs. If you don't input job queries, our job recommendation system will still return a list of jobs the system feel they are mostly interest to you. You can also search the other information other than the jobs and LinkedIn. For example, you can search people. For recruiter, you can search candidates. And for salesperson, you can search leads at LinkedIn too. And we'll also do the people recommendation. Like people you may know, we recommend the people to you to get connected, to grow your network. When you go to your homepage, you will see all the contents, including the articles and the posts. And you can search them based on content search. If you do not provide the queries, we'll still show you based on the recommender system. For the ads, it's also kind of recommendation system. There's no query, but we figure out the most relevant ads for you and to show you. So LinkedIn have different search verticals, like people search, job search, So query understanding is a challenge task because you need to figure out all the different user intentions here. For example, you give a machine learning, it could mean you are looking for the machine learning related jobs, but it could also mean you are looking for someone with some machine learning skills or an article or content on the machine learning topics. It can also mean you are looking for learning courses focused on machine learning or member profiles with the machine learning skills. We can see we have different applications for the search recommendation. And recently, deep learning also becomes more and more popular for search and recommender system. Why? The first reason is deep learning is better at understand the deep semantics from high-dimensional sparse data, which often appear in the search and the recommender system. For example, text information, normally are high-dimensional and sparse. The second reason is deep learning makes the feature engineering much easier. With all those deep neural network, we can easy to learn very high quality feature implementation. This is more efficient than manual feature engineering efforts. Also, deep learning model provide much more flexible models. With all those neural network components, you can easily build the different model for different applications. And deep learning also provides multi-level feature implementation, which is very important for understanding the query and the users in the search and recommender system. For example, we can provide the character level, token level, word level, phrase level, sentence level to understand the text information. Linking also adapt more and more deep learning technology for our search and recommendation systems. We use in two areas. One is used to generate features. So we learn the representation and learning and provide the powerful feature to all different products like word embedding. Another one is we use for the models, the powerful models for different products. For example, the CNN, the BERT model, sequence skills model has been used for linking products. Here are some examples, shows great impacts for deep learning technology in the search and recommender system. For example, we use the CNN model and the BERT model for our people search, job search, ads, click, prediction, ads conversion. We see significantly improved offline. When we deploy those models online, they also show great impacts on the business metrics. Like for the job search, we see the significantly improved on job apply click. When we use deep learning based query understanding model, like for query suggestion, and they also improve the user experience significantly with all those business metrics lifting. So we can see deep learning become more and more popular for the search and recommender system. That's why today we come here together to learn how to build deep learning based search and recommender system step by step. So next, I'm gonna switch to my colleague Jun, give you an overview about our tutorial.
Thanks, Paul, for walking over deep learning and search recommender systems in general, as well as application and LinkedIn. Now, let me tell you more about what you can expect for the rest of the tutorial. The tutorial will be divided into 3 parts. reflecting the major components of a search and recommender system. The first part is query and user understanding, followed by candidate retrieval, and the last, not the least, learning to rank. The query and user understanding task is typically preparing for the later stages of the tasks. It will gather useful information for candidate retrieval and ranking. One typical task could be to infer the intent of the user so that we can serve more relevant result for the user in such a system. In the candidate retrieval stage, we got all the useful information from the user and query understanding. Now we need to gather all the candidates so that we can rank them to provide the results for the user. Typically, there are two ways to do such kind of retrieval. The first one is more of lexical-based, more about word matching. The second way is about semantic retrieval. Obviously, there are other ways to do candidates. For example, if you're dealing with a feed or news feed recommendation problem, then there are all different kinds of signal you can use. For example, if we know that the user are interested in certain topic, certain people, or certain website, you can use all those things to generate possible candidates for the ranking system to provide more relevant content for the user. Once you generated this candidate pool, you can move to the ranking stage. There are different strategies for rankings. We'll be talking about point-wise, pair-wise, and list-wise rankings. Now, there are also common networks can deal with this kind of problems. For each of the session, it will be further divided into two parts. The first part I talked to you about already. That's about the presentation. Then it will be followed by a hands-on session. For the query and user understanding, we'll be telling you about an intent classification model built with our very own DTEX framework that is open sourced by LinkedIn. We'll be also talking about query auto-completion models. By itself, it's quite interesting that it's a mini recommendation system. Then for the candidate retrieval part, we'll be talking about Elasticsearch, which is a popular search engine, which can also be used for recommendation problems. We will also show you how you can use Elasticsearch to do embedding-based retrievals. Also, we'll be talking about a few approximate nearest neighbor algorithms. For the last hands-on session, we'll be focusing on mixed effect model with LinkedIn open source implementations, GeoMix and GGMix. For the global effects, we'll be talking about large-scale linear models, as well as a DTEX-based model. For the random effects, if time allows, we'll be talking about how you can do that on your device with TFJS. Each of the sessions, you will be provided a Python notebook. And for the first two parts, those Python notebook can be conveniently followed directly on either Google Colab or Azure Notebook service. For the last part, It will be demonstrated on a local machine with the Docker image. You will need to download the Docker image to your local machine. I will encourage you to do that because it's going to take some time for the Docker image to be downloaded to your computer, depending on your internet speed. So if you start it now, while you're participating in the first two parts, while you're ready to the third part, your Docker image will also be ready for you. Well, hope you will enjoy the rest of the tutorial.